Section 8.6 is on solving rational equations and inequalities. A rational equation is an equation that contains at least one rational expression. To solve a rational equation, we want to multiply the entire equation by the least common denominator of the rational expressions in the equation. This will eliminate the fractions. That's really cool. You must check your solutions because anytime you multiply by an algebraic expression, you can introduce extraneous solutions. So let's take a look at a couple examples here. First one is 4 over x plus 2 equals 5 over 2x plus 3. Actually, the first thing I want to do is identify the values that x cannot equal. In other words, what are those values of x that are going to make my denominator equal to 0? So since one of my denominators is x plus 2, x cannot equal negative 2. And my other denominator is 2x plus 3, so x cannot equal a negative 3 over 2. So let's see, my common denominator, actually, no, I'm not going to do common denominator for this one because this is a proportion. When you have fraction equals fraction, you can just cross multiply. So 5 times the quantity x plus 2 is equal to 4 times the quantity 2x plus 3. Let's go ahead and distribute. So 5x plus 10 equals 8x plus 12. Subtracting 5x from each side gives me 3x. Subtracting 12 from each side gives me a negative 2. So x is equal to a negative 2/3. That was not one of my excluded values, so that's good. So let's go ahead and check that. I want to plug that back into my original. So is 4 over negative 2/3 plus 2 equal to 5 over 2 times negative 2/3 plus 3. Oops, negative 2/3 plus 3. And that's going to be is 4 over 4/3 equal to 5 over 5/3. And please do use your calculator, and it does check. 1/3 equals 1/3. It checks, so my answer is x equals a negative 2/3. Anytime you're checking, remember you're plugging it back into the original equation, and you're liable to get some really kind of gnarly looking things, but go ahead and use your calculator to help figure it out. Second example here is 1 over x squared minus 5x plus x minus 7 over x equals 4 over x squared minus 5x. Let's first take a look at our excluded values. So x cannot equal 0. Let's go ahead and factor this. So that's going to turn into an x minus 5x, as will this one, x times x minus 5x, so x cannot also not equal 5. My common denominator is going to be, that's kind of nice, x times x minus 5. So I'm going to take my whole fraction here and multiply. I'm going to move that over. Let's move that over here. X is not equal to 0 or 5. And I'm going to multiply the whole thing by x times x minus 5. If it helps you to say that you're putting that over 1, go ahead and do that. So I'm going to take this expression and multiply each of the three parts of the equation by that. So when I distribute to my first fraction here, you can see the x and the x minus 5 are going to cancel, and that leaves me just with a 1 on top. When I distribute to my second expression, x minus 7 over x, the x's are going to be canceling, and I'm left with the x minus 7 times x minus 5. And then when I distribute to the expression on the right of the equal sign, you can see the x times x minus 5 is going to cancel, and I'm left with just a 4. Okay, nice. What's really cool about this is when you do this, you get rid of the denominators. You get rid of the fractions. You've canceled that out. And so I just now have an expression I need to solve. Foiling that is going to give me x squared minus 12x plus 35 equals 4. And I'm recognizing that this is a quadratic equation because it has an x squared in it. So I'm going to make it equal 0. So I'm going to have x squared minus 12x. And then here I have a 36 minus 4 is going to give me a 32. And that equals 0. Let's factor that. That factors into an x minus 4 and x minus 8 equals 0. So x is equal to 4 and x is equal to 8. And we need to check each one of those. So plugging in 4, I'm going to get 1 over, plugging 4 into here is going to give me 16 minus 20, or a negative 4, plus plugging in 4 is going to give me a negative 3 over 4. Is that equal to 4 over, and I did that before, that's going to give me a negative 4. So is negative 1/4 plus negative 3/4 equal to negative 4/4? Indeed it is, and that one does check. So x can be equal to 4. Let's check 8. So that's going to be 1 over 8 squared minus 40. 8 squared is 64 minus 40 gives me a 24, plus plugging in an 8 here is going to give me 1 over 8. Is that equal to 4 over 24, which I did earlier? So that's going to be 1/24 plus 3/24. Yes, that is equal to 4/24. So my second answer checks, and x is also equal to 8. And then don't forget, I did have to check and make sure that neither of my solutions is 0 or 5. Now, a rational inequality is an inequality that contains at least one rational expression. To solve a rational inequality, there are several steps. We're going to identify the excluded values of the variable, as we did before. We're going to solve the related equation, so solve it with an equal sign in it. Then we're going to use the excluded values and the solutions that we'd found to divide a number line into intervals, and then we need to test a value in each of those intervals to determine which intervals contain the values that satisfy the inequality. This is a little more complicated, but let's take a look at a couple examples here. So here I have x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. My excluded values, the only thing I have in the denominator is an x minus 2, so x cannot equal 2. And let's go ahead and solve this as though it were an equation. My common denominator is going to be a 12 and an x minus 2. And go ahead and put that over 1 if you want. And we need to distribute that 3 times to each part of this inequality. So doing the first one, the 3 is going to cancel with the 12 and leave me with a 4 on top. And I still had the x, and then I have an x minus 2. And then minus, when I do my second one, the x minus 2's are going to cancel, so I'll have 1 times 12, which is 12. Remember, I'm going to solve the related equation, so I'm going to put an equal sign in there. And then when I distribute to my last fraction, the 4 and 12 are going to cancel and leave me with a 3. And then I still have the x plus 1 and the x minus 2. So let's go ahead and clean that up. So that's going to give me 4x squared minus 8x minus 12 is equal to, let's see, I'm going to go ahead and multiply these two here. X squared minus x minus 2, and then let's multiply that by 3. 3x squared minus 3x minus 6. And again, I notice I have a quadratic equation, so I'm going to set it equal to 0. That's nice. When I subtract 3x on both sides, 3x squared on both sides, I get an x squared. Adding 3x, I get, minus 5x. And then adding 6, I get a negative 6 equals 0. And that can be factored into x minus 6, x plus 1. So x is equal to 6, or x is equal to negative 1, and neither of those were my excluded value, so that's good. So now comes the complicated part. So what I need to do is create a number line and put my solutions and my excluded value on there. So a negative 1, 2, and 6. And you'll notice that that divided the number line into 4 intervals. So values that are less than negative 1, values between negative 1 and 2, values between 2 and 6, and values greater than 6. Now I need to test a point in each region there. So for this, I'll start on the left here. So for this region here, I'm going to test x equals negative 2, and I'm going to go ahead and plug that in. On this region here, I'm going to test x equals 0. Always use 0 if you can. In this region here, I'm going to test x equals 3. And in the last region here, I'm going to test x equals 7. And I'm going to go ahead and stop the video, fill this in, instead of taking up extra time while you watch me do the work. Okay, so I went ahead and did the tedious work of plugging in the values of -2, 0, 3, and 7 into the original inequality and seeing if it basically works in the inequality. And so when I plugged in -2, I found that -2 did work. So that interval there is going to be a yes. And then I plugged in 0 and found out that 0 did not make the inequality true. So the interval between -1 and 2 is going to be a no. When I plugged in -3, I found that yes, that did indeed work. So the interval between 2 and 6 is going to be a yes. And then when I plugged in 7, I found that that did not work. So the interval where x is greater than 6 is a no. That does not work. So what does my final answer look like? In other words, if I were to graph this, it would be this part here and this part here. So how do I write that as an inequality? Well, I would say that x is less than, and it's not a less than or equal to because my original problem had a less than. X is less than -1, or, because remember there's more than one part here, or x is between 2 and 6. So that's what my final answer would look like. It's a little complicated, so it's like a couple steps beyond solving a rational equation, but it is absolutely doable. And the last example I have here, I think what I'm going to do is I think I'm going to stop the video again, work it out, and then you can take a look at how I did that. So here's my last example. I went ahead and worked it out. So looking at this, I found that the excluded value of the variable would be x is not equal to 0. My common denominator is 9x. Distributed that to each of these terms and solved the related equation and came up with that x is equal to 15. Then I drew my number line, and remember the two values that you put on there are any excluded values and the solution to the equation that you solved. So that creates an interval where it's less than 0, an interval between 0 and 15, and an interval greater than 15. So I went ahead and tested points in there. So when I tested -1 for this first interval, that worked. So this region is a yes. When I tested +1, which is in this middle interval, that did not work. So that area was a no. And then I tested x equals 16, which is greater than 15, and that did work. So this area here is a yes. So if I were to graph this inequality, it would look something like this. And that is a straightforward OR inequality. So my solution would be x is less than 0 or x is greater than 15. So in this section, we took a look at how to solve rational equations and inequalities. To solve a rational equation, you want to multiply the entire equation by the common denominator. That will eliminate your denominators and give you a regular equation to solve. In solving a rational inequality, it's a little more complicated. We solve the related equation and set up a number line with the solutions and the excluded values, and then test values in each of those areas to see what works. And because it's an inequality, your solution is going to be an inequality.